Okay, we're going to try and find the equation of a sinusoidal function that has a minimum of 2, 1, has a period of 8, and has an amplitude of 3. We've got several different conditions, but first thing is, if this is a sine function, we know that they generally are going to look like this. They're going to be nice and symmetrical. A period is going to go from the beginning point here to the end point is 1 period. So in this case, I know from here to here must have taken me 8 whatever. That's my length of time. And the amplitude, so from here to here, would be 3 and 3. So these are going to be some things that are going to help us out in terms of figuring this problem out, looking at what this looks like. So I'm going to kind of just sort of initially give me a little basic sketch here of what this looks like. So I'm going to sort of, just for myself, I'm going to sketch this out a little bit. It doesn't have to be perfect. I just want to get a general idea what this looks like. All right, so here's what I know. I know my first point that I'm going to be looking at, the lowest point on this graph is at 2, 1. So at 2, 1, I've hit sort of the minimum. Okay, now I know that I've got this amplitude to factor in, so oops, I'm gonna undo something. Sorry about that, but I'm at is 2, 1. And I know that that's the base to this. So I'm going to go ahead and see if I can look above and below, see what I can figure out here. So what I've got then is 3 above this, 1, 2, 3. Should be sort of this midline. And then 3 above that would be the highest we can go. Okay, so that would basically be this point here, just so you can have a reference point. So if that's 8 all the way across, that means from here to here, I'm going to mark it a different color for us. So here to here would be 2, here to here would be 2 more, here to here would be 2, and there would be 2. So halfway would take me 2 spaces, an additional 2, that would give me 6, that would give me 8. So I know that 2 spaces over, and 3 spaces up, 1, 2, and then 3 spaces up should give me that endpoint. If I go the other direction, 2 the other direction, and 3 up. So 1, 2, 3 up. That should give me that point. 2 over, 3 up. That's going to give me this point. And 2 over and down is going to give me that point. So now what I have is a graph that kind of looks like this. All right, it looks exactly like that sine one, only my initial point has been shifted over 4 spaces. So this is all going to become important to us as we start figuring out what this looks like. Okay, so we'll come back to this idea, but that's the general sketch really quickly. So let's see if we can use that as we move on. So what I'm looking for is an equation of A sine of bx minus c plus d, where each one of these letters is going to represent amplitudes or periods or whatever it happens to be. So the first thing I know for sure is the amplitude. So I can tell you right now that this is a 3. I still have my sine, still have my y equals. I've got to see if there's any other values I know here. So what I do know is that if I want to solve for b, what I'm going to use is a little side equation here that says that 2 pi over b is equal to my period. Okay. So if I multiply this out, I've got 2 pi is equal to 8b. But I want b by itself, so I'm going to divide. So I've got 2 pi over 8 is equal to b, or b is equal to pi over 4. So I now have another value I can put in here, pi over 4. Now I've got to see if there's anything else I can solve for. Okay, so if I want to find my c value, what I've really got to do is find sort of the phase shift. I've got to figure out what this turns out to look like in terms of the phase shift. So I'm going to go ahead and set up an equation of this part here. Put these back in colors. This, I'm going to set that equal to 0 to start off with. Okay, so let me stop for just a second. All right, so I'm going to go ahead and take the pi over 4x minus c, and I'm going to set that equal to 0. So I'm going to get c is equal to pi over 4x. All right, so key here is I've got to find that x. So if I go back to this initial problem here, this is where I'm getting it from. This point is the point -4, 4. So that's my x value I'm going to use, is -4. So c would be pi over 4 times -4, or c would be negative pi. I'm also going to use that to figure out my d. So I'm going to go back to the graph again. How far over did I move this? Well, we already said that was 4. So this is my d values, how far I vertically shifted it, horizontally shifted it. Those are the two shifts that we need to worry about. I'm going to go ahead and put that all back into this. And so what I'm going to end up with then is I'm going to end up with a final equation that says that y is equal to 3. That was our amplitude. Sine of pi over 4x, which we solved for using that formula for the b value, minus a negative, so we're going to have plus pi, and then plus 4. So each one of these values came from a different part of this. This came from taking the 2 pi over b and setting u equal to 8 and solving for our b value. So the key to this one was to find the b. This one here came from us taking the inside value, that pi over 4x minus c, and setting it equal to 0. And then using that x value from our, technically our new origin, if I guess we want to call this, where we had our new original point 2. And then this one came from how far we moved it vertically, or I mean horizontally. So we knew across the page we moved it -4, which in order to get it back to 0 would mean a +4. So this was our location for all of our values. That's how that came about. And that graph should now give us something that meets all of the initial criteria.